All right, Chapter 7 Mapping to Identify Possible Factors. In this chapter, characterizing a process by mapping its flow, sequence, and steps, getting a high level view with a SIPOC, CPOC, and gaining perspective with value stream mapping. A map of your location and your surroundings is invaluable whether you're looking for a store at the mall, navigating your way across a busy city, or trekking on a mountaineering expedition. In the same way, a view of the current state of your processes, whether in traditional flowcharts or as value stream maps, is invaluable, if not essential, in your Six Sigma improvement efforts. It captures the current state of how work is accomplished, what resources are used, what equipment and materials come into play, and so on. Without a map, you may think you know what goes on in your process, but you'd almost always be wrong. You may be surprised how often managers lose track of things such as invoices, production capacities, inventory levels, rework, and bottlenecks. This type of information must be accurate and current in order to make good decisions about improving a process. In this chapter, we show you how to define a process and create a CPOC, a helpful tool for getting a high-level view of a process. We show you how to use a process map to capture and document the current as-is state of a process. This tool guides you in knowing what subsequent work your process needs and where you need to allocate resources. We also introduce value stream maps, which capture the overall end-to-end process. Keep your process maps current and accurate. As your processes change, your maps must change. If you don't keep the process maps up to date, you don't have a reference definition of what's happening in your organization. Breaking down process flow. In Six Sigma, you want to define a process very precisely, down to the last detail of activity, resource, decision, dependency, and values. Sometimes this level of definition is the only way you can sufficiently measure and analyze a process, leading to breakthrough improvements and, ultimately, effective controls. Mapping or modeling the process is a representation of this precise process definition, and the practice of process modeling is therefore fundamental to Six Sigma. A process map looks like a flow chart, and at the top level, that's exactly what it is. A process map is a picture of the activities and events in a process. Figure 7-1 is an example process map. And the font is kind of thin, so you might not be able to get it. Yeah, I can't get this one. Sorry. You gotta buy the book. Map your processes as rigorously as you need to in order to see the big picture as well as the tiny details. Take the time to build your maps properly. They cross boundaries and borders, and sometimes the act of creating a map causes you to uncover issues and even step or stomp on a few toes. But don't despair. Process maps speak the truth. They form the basis for increased levels of understanding and breakthrough improvement. The time you spend building the map reaps its rewards in performance and satisfaction. Six Sigma process mapping begins with building flowcharts. You then annotate and define the paths, encounters, decisions, and destinations on these charts in quantitative terms, including such measures as value, time, resources, yields, and the statistical distributions around each. In this section, you discover how to create the perfect Six Sigma process map. Drawing a process map. Process mapping has been practiced for decades, and the fundamental concepts around process maps are nothing new. The Six Sigma style of process mapping has a few different aspects, however, so you utilize a few new features from its flowchart ancestors. In the world of Six Sigma, you characterize the process map in mathematical terms, so you can perform a plethora of statistical analyses on its various parts and pieces. You back each step, function, and activity with numerical descriptions and quantifiable attributes, enabling you to see the process in all its exacting glory. This is great. This is quantitative research versus qualitative research. That's an aside from me. I continue. In Six Sigma process mapping, you characterize a practical situation in ways that let you describe in statistical terms, allowing you to develop statistical solutions that you then apply back into your practical environment. On the surface, a Six Sigma process map can look like a simple flowchart, but underneath, it's detailed, complicated, and mathematical. You can draw a process map with a pencil and paper, or with a drawing tool like Microsoft Visio, but these creations are just drawings. Only with more advanced tools such as ARIS, see Chapter 21 for details, can you capture the details that enable Six Sigma class analysis, simulation, that enables Six Sigma dash class analysis, simulation, execution, and management. Regardless of what kind of tools you use to create your map, following a consistent set of conventions when using shapes, connectors, and other drawing elements is important. Figure 7-2 is an example set of some drawing conventions used in process mapping. Although these icons are typical, the exact shape may vary slightly from one tool to another or from one company to another. Most of the process mapping software applications use the Business Process Modeling Notation BPMN standard. This is figure 7-2, and it's there. Gives you a little, it's like a key. It's like a key for drawing your map, right? It's a key. Okay. As you begin, don't worry about the details of what happens inside each of these boxes. Your goal at this stage is to capture each of the steps, identify its basic function, and connect all the steps in the manner that represents the existing process. Defining and visualizing the process points. After you've drawn a process map, see preceding section, your next step is to define each of the map's objects. You must be precise and quantitative. The accuracy of your process model depends on it. If you're using a process mapping technology tool, such as those we discussed in Chapter 21, your tool includes prompts for the numerous definitions and attributes at each node, step in the map. The categories of process element definitions include the following. Operation cycle time of the process element, including its average time to complete, the variation in time called the standard deviation, and perhaps a distribution curve to represent all the possible completion times as well. Head to chapters 9 and 12 for more on standard deviation and distribution, respectively. Oh, that's great. Okay. Resources used in the process element, including human, capital, and natural resources. The better tools let you identify resources by name and type, and then later track their utilization during simulation. Value added by the process step in the units of measure that mean the most to your organization. At a minimum, you must be able to define whether the process step is value add or value add, VA, or non-value add, NVA. Chapter 11 gives you the lowdown on these designations. And cost of the resources consumed, including the costs of personnel, facilities, direct material, and sometimes even indirect costs. The closer you can come to defining costs in the same terms as your accounting system, the better. Ultimately, you have to reconcile cost and claim value that your accounting department can verify. Get the bean counters involved up front and make them your partners by counting your beans the same way they count theirs. A common practice in process modeling is to employ a visualization technique called swim lanes. As we note earlier in the chapter, processes cross functional boundaries and borders, and swim lanes help you see that movement. In a swim lane process map, time flows from left to right. The process crosses lanes as it traverses departments on its journey from start to finish. As you can see here, these are the swim lanes. Imagine you're the customer in the process map in Figure 7-1. You're in lane 1. As you work your way through customer service and then the banking services, you cross over into lanes 2 and 3. Figure 7-3 shows this action, which I just showed you. Swim lanes are an effective visualization technique that lets each functional contributor to a process understand his role while giving everyone a chance to see just how complicated the process may be within your organization. Remember, each time you cross a lane, you have, in essence, created a supplier-customer interaction that implies needs, wants, and desires that must be met. Acknowledging the as-is state. One way to think about process mapping is as an exercise in defining a better process. How you envision your process can work sometime in the future after implementing the changes that would enable your new concepts. It's the to-be state of affairs, and mapping the future in this way provides you the opportunity to examine your plans in detail and consider your options before implementing the changes. You wouldn't dream of making changes without first modeling them. But first you must create a map of today's reality, the so-called as-is state. Many organizations skip this kind of mapping. They're so eager to dismiss today's problematic world that they leapfrog straight to the dream of tomorrow's possibilities. Big mistake. The only excuse for not modeling the as-is process is if you're implementing something brand new and there's no existing process. Otherwise, if a process exists today, model it first. Doing so accomplishes 3 important tasks. 1, sets the baseline. Before you can measure the effects of your sweeping changes, you must first characterize the present conditions. By using the same process mapping techniques to characterize today's as-is state as well as the future to-be state, you have the basis for measuring the effectiveness of your process improvement effort. 2, it sees the process. Seeing the process involves recognizing that 3 different perspectives exist: what you think is going on, what's really going on, and what should be going on. These views are distinctly different, but characterizing the differences is precisely what you're trying to achieve with Six Sigma. You must replace what you think is going on with what is really going on, and only then can you understand what moving on to the third view requires. And third, it stimulates closed-loop behavior. Your investment in mapping primes the pump for breakthrough performance improvement. To continue the cycle of improvement, your model should be dynamic. Should be a dynamic living entity such that your model is in sync with reality at any point in time. Modeling the as-is condition from the beginning promotes this closed-loop behavior. Developing an SIPOC, or a CPOC. Oh, SIPOC. Okay. SIPOC, pronounced SIPOC, is an acronym that stands for Suppliers, Inputs, Process Outputs, Controls. The SIPOC is a powerful companion to a process map. See the preceding section if you haven't delved into process maps. With this tool, you build your first controlled and organized view of your work process and set the foundation for applying the Breakthrough DMAIC strategy. SIPOC is one of those handy reminder acronyms that contains the terms in their proper order, helping you remember not only the 5 high-level elements of a process map, but also their order. Here's the breakdown. S is for suppliers. Suppliers are systems, people, organizations, or other sources of the materials, information, or other resources that are consumed or transformed in the process. I is for inputs. Inputs are materials, information, and other resources the suppliers provide that are consumed or transformed in the process. P is the process. The process is the set of actions and activities that transform the inputs into the outputs. O is for outputs. Outputs are the products or services that the process produces and the customer uses. And C stands for customer. Customers are people, groups of people, companies, systems, and downstream processes that receive the output of the process. Hearing voices yet? If you've developed a successful SIPOC, you should be hearing voices by now. Who's talking? The voice of the customer, the VOC. These voices are the needs, wants, and desires of the customer, generally spoken as the customer requirements. VOC is the loudest voice you should hear, and it's the voice calling back at your process from beyond the output that offers you compensation in return for satisfaction of its needs and wants. Flip to Chapter 11 for more on the VOC. Voice of the process. The process must meet the requirements of the customer, and its ability to do so is called the VOP. VOP is a construct for examining what the process is telling you about its inputs and outputs, and the resources required to complete the functional transformation. You can read about the VOP in Chapter 13. And the voice of the business. VOB. VOB is the voice of profit and return on investment. At the end of the day, every endeavor has to enable the business to survive, grow, and meet the needs of its employees, investors, and the community. Chapter 5 has more info on VOB. You build a SIPOC from the inside out, beginning at the center with the process map, of course. It's a 6-step approach. 1, identify the process you want to map and define its scope and boundary points. Using action verbs, describe what the process is supposed to do and in how much time. Define its starting and ending points. 2, identify the outputs. What are the products and services that the process produces? 3, define the recipients, the customers, of the outputs by name, title, system, or organizational entity. 4, define customer requirements. What do customers expect? What do they demand? What are they entitled to in their fair exchange of value? And 5, define the inputs to the process. Identify the human, capital, information, materials, and natural resources the process requires to produce the identified outputs. Identify the sources, and 6, identify the sources or the suppliers of the inputs. With this information in hand, you now have a fully contained high-level view of any process. This result alone is one of the most powerful tools you can use because it sets the conditions for the DMAIC of Six Sigma. With the SIPOC, you have the basis for defining and characterizing the process itself, the context for measurement, and the basis for analyzing, identifying areas of improvement, and honing in on your targets of control. SIPOC software tools such as Aris, iGraphics, and SigmaFlow help you capture, organize, and display this information. VSM, charting the value stream. Traditional process mapping. See the section Breaking Down Process Flow earlier in this chapter. Is a powerful way to capture the detailed step-by-step flow, sequence, roles, and resources of a process. But that very detail can sometimes cloud the larger picture. Originating from Japanese manufacturing, another format of process mapping has its advantages. It's called a value stream map and often is abbreviated simply as VSM. A properly constructed VSM provides insight into the end-to-end process in ways that no other method does, introducing a stream of resources, information, and value. The end-to-end chain of activities, events, and processes, which begins with the customer's requirements and includes everything needed to provide the customer your product or service, is called the value stream. It embodies the flow of all material and information through the process steps that come together to create the product or service that has value to the customer. A value stream map comprehensively captures the cross-functional end-to-end entirety of a process. Figure 7-4 is an example of a value stream map for a manufacturing process. You're really going to need the book for this one. I can't. Okay. Imagine you're in your customer's shoes and can view how the product or service comes into being. Working from the right, you, through the customer's eyes, receive the item. Before that, it's configured and prepared for shipping. Even earlier, steps are performed that create or assemble the item from raw materials. Raw materials are ordered and received from various suppliers. The earliest event is your actual order or request, either direct or anticipated for the item. The primary advantage of capturing a process with a VSM rather than using the traditional flowchart approach is that you see the entire end-to-end process. Too often, traditional flowcharts allow you to review and improve only a part of the process, the sub-process. This localized improvement often leads to unintended problems that crop up in other areas of the value stream, or simply shift upstream or downstream instead of being eliminated altogether. A value stream map forces you to see the entire end-to-end translation of resources and materials into a valuable result. That way, you're less likely to improve one section of a process at the expense of other areas. VSMs aren't the be-all and end-all, though. A VSM by itself doesn't provide the level of internal details needed to isolate and improve the root cause of poor process performance. A VSM's focus is on flow of materials, flow of information, the capacity and reliability of each individual process, and so forth, not on the internal goings-on at each stop. Supplement your VSM with detailed process maps. Where they are needed, supplement your VSM with detailed process maps where they are needed. Doing so gives you the best of both worlds, an end-to-end customer-centric view of the process and the level of focus and detail afforded by traditional process maps. Creating a VSM for your process. In this section, we provide a quick guide on how to create a VSM for your process. You can find a lengthier treatment of creating and analyzing value stream maps in the latest edition of Lean for Dummies by Natalie Sayer and Bruce Williams, Wiley Publishing. Here's a quick rundown of the process, of the creation process. The following sections cover the blow-by-blow details. 1. Assemble a cross-functional team that has representatives from all areas of your process. 2. Consider the customer. 3. Draw the customer near the top right of your VSM and capture the events or signals that trigger the start of the process. 4. Capture the process steps. 5. Add the process timeline. 6. Summarize the key operational metrics for your process on the VSM. And 7. Identify improvement opportunities. Getting team input. Because of a VSM's end-to-end scope, you need to gather input from a wide set of domains: production planning, supply chain, inventory, stores, manufacturing, shipping, and so on. Including all these inputs is critical to creating an accurate and useful VSM. Starting with the customer. After gathering inputs, consider the customer. In the example shown in figure 7-4 earlier in the chapter, you can see the product customer drawn toward the upper right. Ask yourself what the customer does to signal the need to start the process. Does it place an order? Does the signal come from a forecasted customer demand? Whatever the impetus is, the customer always does something to start the ball rolling. Draw the customer near the top right of your VSM and begin by capturing the events or signals that trigger the start of the process. To follow typical VSM conventions, use thin, solid lines to indicate signals or the flow of information in your process. Use thick, solid lines to designate external material flow, like from a supplier, and use thick, dotted lines to document material or flow that occurs within your organization. In the example shown in figure 7-4, you can see a customer order being first routed to production control. Production control in turn sends out forecasts and weekly material orders to suppliers. In a parallel path of the value stream, the production supervisor also receives a signal from production control and sends out daily production instructions to each of the process steps. Capturing the process steps. Next, you want to capture the process steps. Usually you place the as-is internal process steps at the bottom of the VSM in a horizontal layout. These steps are designated by blocks with characteristic measures for each step. Capture as much information as possible about each step, including cycle time, changeover time, number of operators, number of pieces, work in process, inventory quantities, reliability, yield, and so on. The more information you capture, the more insight you gain. In Figure 7-4, you can see the internal process steps along the main horizontal of the diagram, starting with machining and proceeding to honing, deburring, inspecting, and packaging. Process mapping and VSM aren't armchair activities. You must physically go to where the process is conducted to gain the greatest insight regarding the as-is process. Never neglect this important effort. Genchi Genbutsu is a Japanese improvement term that means go and see. Genchi Genbutsu. Go and see. The phrase reminds you that to truly understand a situation, you must go to Gemba. Let's go to Gemba, another Japanese term meaning the real place where work is done. Adding the process timeline. Value stream maps contain a unique feature, a highly insightful timeline, beneath the horizontal line of main process steps. As you can see in Figure 7-4, the timeline captures not only the time required for each step, but also the time spent waiting between steps. In this way, you document how long the entire process takes to be completed from end to end, the cycle time. The timeline also includes a vertical component. To highlight waste, any segment of process time that doesn't add value, see Chapter 11, is drawn in the timeline with an elevated step. So in a glance, you can see what portion of overall process time is spent adding real value and how much isn't. You'll almost always be surprised to discover how much elapsed time in an as-is process is non-value add. Often it's over 95%. Use the timeline component of your value stream map to capture and communicate this waste and improvement opportunity. Don't confuse takt time with cycle time. Cycle time is a measure of how long a process takes to complete. Takt time is the pace needed to exactly meet customer demands. Takt is a German word that means beat. It's calculated by dividing the available production time by the number of parts needed to meet customer demand during that available time. To minimize waste, a process should produce its output no faster or slower than the customer-determined task time. Otherwise, waste occurs. See Chapter 11. When you compute takt time, take into account your current production efficiency. A realistic takt time is multiplied by your efficiency number. For 80% efficiency, multiply the takt time by 0.8. This step means you build in enough capacity that you can meet customer demand while sustaining production losses of 20%. Of course, you shouldn't be satisfied with an 80% performance. Find the root cause of your production losses and work to improve your performance. When you realize efficiency improvements, adjust your takt time accordingly. This adjustment will have an impact on your production schedule as you strive to meet customer demand. Supplying the box score. Place a summary of the key operational metrics, known as the box score, right on the VSM, usually near the top. Be sure to include the total lead time, including the value add and non-value add items. You may also include information like the total distance traveled, total parts per shift, scrap, pieces produced per labor hour, changeover time, inventory turns, uptime, downtime, whatever is critical in your situation. Identifying improvement opportunities. With your VSM in hand, you immediately begin to see opportunities for improvement. A few of our favorite improvements include the following. Reducing or eliminating waste. Anything in the process that doesn't contribute value to the customer should be a candidate for improvement. Matching or balancing cycle time with takt time. Ideally, each step of the process should match the pace needed to meet customer demand. Cutting back on bottlenecks and flow. Think of a smooth flowing river. Anything that chokes, diverts, or disrupts the flow of your process is a candidate for improvement. Decreasing inventory. Reduce or implement unnecessary inventory, whether that's raw materials, work in process, or finished goods inventory. Speeding up changeover times, the ability to rapidly switch production from one item to another, opens up a new dimension of adding value to the customer. For example, quick changeover times allows you to hold less inventory because you can respond rapidly to changes in customer demand. Improving information flow, the right information gets to the right people at the right time. Optimizing physical layout, reconfigure the layout of the process to eliminate or reduce movement and transportation. Standardizing work, deviations from set patterns always lead to an uptick in waste. Which process steps need better or improved standards? Maximizing equipment uptime and availability. Equipment issues no longer limit the effectiveness of your process. And enhancing process capability. This category of improvement is what the analytical tools of Six Sigma are geared toward. You can make dramatic breakthrough improvements on how well the output of each process step meets customer requirements. And here, in focus, totally in focus, is figure 7-4. I can't fucking figure this camera out. Okay, this way. What a nightmare. This camera sucks.